All right, our last session for Unit 8, the last section of Chapter 7, quadratics. Last few kind of contextual problems we're going to tackle here. Let's see what we come up with. So number theory and distance problems, test type questions. All righty. Let's see. First one says, two positive integers differ by 5, and they have a sum of 233. Two numbers differ by 5, so that'd be like 10 and 5, they differ by 5, or 7 and 2. So how could we represent those? Let's say the first one is x. How would we get the other one? Well, I guess we'd subtract 5 from it, x minus 5. So those are two positive integers that are going to differ by 5. Okay. It says which equation could be used to find these integers? Okay, let's see now. We want to write an equation that says their squares have a sum of 233. So the square of the first one, and we take the second one, and we square it, and they have to have a sum of 233, thusly. Okay, so that looks pretty good to me in terms of their squares having a sum of 233. So that looks like this equation. I guess that's the correct one. So which one are they, what are they trying to fool us with on the others? Oh, I see here they've got the square in the wrong place. Here they've got the same thing, but they sort of switch these back and forth. Oh, look at this one, they squared the 5. Oh yeah, okay. So just sort of different formatting on the equation that they might try to trick us up with there. Be careful. Not a bad question if you keep your wits about you. A little bit tricky to put it down, but not too bad. Okay, a small boat leaves Dundee at noon. I'm going to assume this is Dundee, Nova Scotia, not Dundee, Scotland, but it doesn't really matter. So it's traveling north at 12 kilometers per hour. So if this is Dundee, the first one is going north at 12 kilometers per hour. All right, at the same time, oh, that makes it easy. Another boat heads east from Dundee at 16 kilometers per hour. He's going faster. Okay. After how many hours will the boats be 40 kilometers apart? So they got to be 40 kilometers apart in distance. Now these are speeds we have here and here. So if we want to turn those into distances, we've got to use our d equals vt equation. So d equals vt, distance is speed times time. So the first boat is going to travel a distance of 12t, where t is going to be the number of hours after noon. And the second boat will travel a distance of 16t. Okay, so we can use Pythagorean theorem to figure out what t is. So we can say that 12t squared plus 16t squared has to equal 40 squared. Okay, so 12t squared is going to be 144 t squared. 16 is 256 t squared, and that's going to equal 1600. All right, now this is a quadratic. There's no linear term. There's no term with just a t in it, but it is a quadratic. We've got a couple of squared terms here. Let's put them together. Combining like terms, we have 400 t squared equals 1600. Okay, that's a pretty easy quadratic to solve. Now you could, if you want, divide everything by 400 here, and that'll make life simpler. And then we have t squared equals just 4. Now, the brute force method here would be to subtract 4 from both sides and factor. The quicker way would just be to take plus and minus square root of both sides. I'm going to use brute force, I think. So we've got t squared minus 4 equals 0. So factoring, that's a difference of two squares. We have t minus 2 times t plus 2 equals 0. And then using our zero product property, that tells us if t minus 2 equals 0, then t has to equal 2. And if t plus 2 equals 0, then t has to equal minus 2. Okay? I don't think they went back in time, so let's say it's about 2 o'clock in the afternoon, because it was noon when they left. So at about 2 o'clock in the afternoon, those two boats are going to be 40 kilometers apart. Okay, 2 hours. So remember, write an equation to model a relationship with the variable representing your unknown quantity for a number theory problem. The d equals vt is the big thing for the distance problems, for moving objects, and then Pythagorean theorem other than that. Otherwise, remember, not finding vertex. No, this is not a max-min problem. We're just finding roots. Okay, good luck. See you in the next unit.